explaining top dead center, bottom dead center, and what to do when you're given both the stroke and bore. You are given that, but you are not given V1, V2, but rather you know the ratio between them. Or you're given V1 is 9.8% of V2. Then you can get your R, which is V1 over V2, and we know that V2 is 9.8% of V1. So V1, 0.098. This gets cancelled. You're left with 0.098, and this is 1. Sorry, don't mind that. This is your R. Now, once you have your R, you can then simply find the other aspects of the equation. Now, in this case, or in the problem that I'll be referring to, practically it's asking us for the total, not the specific work. So usually when we're going to do equations like this, we usually disregard mass. But in this case, we need to find for mass to be able to get our work, not specific work. With that in mind, we can then continue with our discussion. So when we have a stroke and a bore, this is your bore, the diameter of your cylinder, of your car cylinder, and then your stroke is practically the one I drew, which is this part here. Now, bottom dead center, your piston is right over here, but the top dead center, it's right over here. Now, we can't just assume that that's your total volume for your cylinder, because of course we have a clearance. And then again, assuming that we aren't given V1 nor V2, but rather the ratio, we can find V1 by this manner. So we know that the total volume is just our clearance volume plus the swept volume from the stroke and the bore. Once you know that, you're already almost there. We just need to find our clearance volume, and something to note, at clearance volume, it's also equals to V1. So our total volume is these two things. And let's go back to the idea of what compression ratio is. It's a max volume over the minimum volume that you have. In our case, it's the bottom dead center, the biggest volume, max, and the smallest volume, which is our top dead center. And that will be denoted as your total volume, since it's this entire thing, over your VC, which is your leftover volume. We are left with this equation. It's equals to R, and we can expand VT as VD plus VC. After that, combining these two, we get 1 plus VD over VC. Now, in this case, when we already have the other P1, T1, R, and then we just need V1 to get our mass, to get our exact work, we can then get our V1, since we know our stroke and our bore, we know these two things. We know that if we take the diameter, the area of the circle, then times it with the length, we get our volume for our displacement. Then we divide that with our VC plus 1. But we are finding for this, and since we got R, from R equals V1 0.098, we can substitute that over here. Then we can then find for VC, as we already know what our swept volume is. Then this VC is just equals to V1, as I said earlier, right over here. Then we can substitute it back here to be able to get our mass. Once we have our mass, we just multiply it with other cylinders that we may have. For example, if you have 6, multiply it by 6, 3, 3. Then you can get your total mass that your system has. Then you can get that for the other parts of your heat and your work.